Thank you.
Welcome.
Lembra? Fica segurando e ele vai acender. Bom. Mas aí depois você vai apoiar o melhor. Então, mas para nós a gente faz algumas coisas isso lá. Tem questão de agressão. Então, eu acho que tem que ser uma coisa briga do tempo. É o tradicional. Né? Então, eu vi presidente, eu estava pensando, foi comigo, como só que aí, não sei se eles vão fazer então, é isso
Falado, eu ia vir dele, mas eu.
Okay, good. Alrighty. Okay, everybody. People are already raising their hand for me. Thank you. All right. So I think that module 5 set us up really good for module 6 that kind of starts explicitly looking at how to use generative AI as a problem-solving tool and a design tool. So this oftentimes comes from a student's perspective, but I think this is something that can be applied even to a faculty perspective. Obviously, we were kind of testing it out before, playing with it, actually solving our own prompts and stuff. So I think you can kind of see how these relate to each other a bit. So just again, we're going to go through what I'm calling the solve method, which takes kind of a popular problem-solving method and tries to kind of come up with a fun pneumatic way to remember each aspect of it, but specifically kind of relating it to that relationship with AI we were talking about, which is that back and forth. So, ensuring you have that human-in-the-loop collaboration with AI rather than just relying on it as like a catch-all or some magical solution. Then we'll also talk about leveraging generative AI, both, again, emphasizing it as an intelligent assistant rather than that magic solution, and actually looking at those applications. So at a high level, what solve is structuring the problem, outlining your solution approaches, learning and generating from the solutions that you receive, validating and verifying the solution you choose, and then evolving and improving based on the outcome of your implementation. So I'm going to go through each of these pretty quickly so that we can kind of jump into the worksheet. I have, again, on module 6 in that folder, 3 parts. The first part is just if you want to take some notes about the solve method, and then part 2 is when we'll actually jump into the activity. So we look at structuring the problem, looking at Woods, who comes up with this sort of problem-solving methodology. He says, we must be able to understand and define our problem. That's like the very first step to actually solving it. So when we look at how that looks with our collaboration with AI, I think you can kind of see it goes human AI, human AI. It's that volley back and forth. So an example of this would be, we define the initial problem that we have. We know what we're trying to solve. We might not have all the details yet, but in a vague way, we can come up with a statement about what it is we're trying to do. AI will probably suggest some alternative problem framings to kind of help encourage some thoughts around what are some details I'm missing from this problem that I can add to come up with a better, more accurate solution. You actually evaluate and refine the definition, give it back to AI, and it will help you kind of identify those key components and relationships that you need to actually implement the solution around in order to solve the problem. O, which is outlining your solution approaches. So once you have that definition, it's time to actually explore and find different ways to represent the problem. So again, following that human AI pattern, we can actually provide our engineering constraints and requirements that we've kind of conceptualized from that original back and forth around the problem definition to AI. It's going to come up with those solution approaches. So previously it was coming up with different framings of the problem to encourage those details to kind of emerge. Now it's actually going to start coming up with multiple solutions to the problem that might fit your context. So it's that brainstorming phase. It's again your job to evaluate the feasibility of those solutions and sort of rank them based on those feasibilities and select the ones with the most promising direction. And then again, you give it back to AI and it can provide that detailed exploration of what an outcome might look like if you implement those kind of ranked solutions. L, which is learn and generate. So now it's actually time to pick a solution and execute it. So this is kind of the exciting part to me, especially because you're still collaborating with AI while you're taking it out into the real world. So as a human, you're providing those specific requirements and guidance. So you take that solution, you're enacting it, and now it's your turn to give feedback to AI about, is it aligning with the outcomes they anticipated for this solution? AI is going to generate some detailed solutions or implementations to those sort of quirks that you've identified, maybe misalignments. And then you review and provide feedback for that continued refinement. And AI is going to iterate kind of based on those human inputs and requirements. So you might have to go through this solution definition and implementation multiple times as you continue to kind of pinpoint what it is you're trying to do. At the end of this, you have validate and verify. So this is actually emphasizing the importance of checking and evaluating our outcomes, which is a common theme I think we've all recognized through these different modules we've had. But you're basically just trying to ensure the quality here. So human defines the validation criteria and standards. So what does success look like to you? You've had these solution framings proposed to you by AI, but do they actually align with like the reality of the situation? What did you expect going in versus what was the actual result? AI can then give you back some systematic checking and verification. So you've given it a framework, and as we talked about before, it's really great with template work. So if you give it the criteria, it can use that. And then as the human, you're evaluating those findings, and AI is going to help actually document all of this. So that's a nice aspect of it, is that the written aspects in the processing of that documentation. And then finally, we have this sort of reflective period of problem solving, which is evolve and improve. So you're just reflecting on the solutions that you have and making some generalizations about your experience. So you as the human are identifying the areas that maybe could still use some improvement. Like you've generated a solution, it's done what it's needed to do, but we always know that we can do better. So what's something that you would like to see change in the future? AI can then suggest optimization strategies and alternatives. Again, your job as always as the human is to evaluate those responses. And then AI can, again, help with that implementation and impact analysis. So in a way, it's sort of just one big loop, which aligns with what we know about engineering. This engineering design process, if you're familiar with like Agile, all these things are just big loops where you're constantly trying to improve the solution that you previously came up with. So now I would like to do an activity. This is that part 2 on the document worksheet in that module 6. But I've kind of given some sample engineering problems. This is kind of building on what I was doing in front of you at the end of the last module. But I have given you that table in the last module of different tools. I'd like you to kind of just pick one, play with it, and put some of these design problems that I've put in the worksheet and just kind of see if you can follow that solve process. It asks you some kind of reflective questions to encourage you along the way. But I think it's an opportunity for some kind of hands-on experience with it. And I'd like to kind of get some feedback on the solve framework for it. So I'll give you guys some time to get started on that. And of course, I'll be around if you have any questions. I think we have about 20, 25 minutes that we'll do to kind of play with this. That works? Okay, have fun. Part two. All right, thank you. My impression is that this is turning out to be more difficult than maybe we all anticipated. That maybe, you're kind of still on the S on the O side of things, which makes sense. It's not easy to define and solve your problems. I don't think anybody necessarily expected ChatGPT or Claude or any of the tools that you're using to solve your problem in 15 or 20 minutes. But it was just an opportunity for us to start kind of playing around with the kind of volleying back and forth with AI. And something we were just talking about is kind of building up that intuition. So one thing I did want to say is, in the examples I showed, it was like human AI, and it was a very perfect 4 times for each one. That's not always going to be the case. The thing with building that AI intuition is kind of, in a sense, knowing yourself and knowing what you want and how you talk and how you want to be interacting with the machine. So if you feel like you're defining your problem in a way that works really well, and it maybe picked up on a few things that are missing, or it made you notice a few things that are missing, and after one iteration of going back and forth with it, it's the solution or it's the problem definition, then that it's a sense of like trusting your gut, trusting your expertise, and kind of knowing when enough is enough, because you can really play around and go back and forth with this thing forever. So that's just something I kind of wanted to leave this activity with, and I hope you guys do continue to play with that method and kind of use it and implement it in different ways and just kind of see if it works for you. Again, it's just kind of a guiding framework to remind ourselves that it's not just input and output. It is kind of going back and forth and having that reflexivity to analyze what we're being given and say, does it align with what I'm looking for? So now we're going to jump into how we can actually start leveraging this generative AI. We started playing with the problem design, but how can we actually apply it to the problems themselves? And the easiest answer I have for that is to be using it as an intelligent assistant, not as a replacement for whatever it is you're trying to do or whatever the student is trying to do. So yeah, it's a support. It's not a replacement. You have your engineering judgment, and this is going to be really aligned with that generative AI intuition that you're trying to build. So your intuition around generative AI are kind of in these 5 major areas. So you should be reflecting on the assumptions and inputs. You should be reflecting on the accuracy and verification around these outputs that it's giving you, how applicable it is to the problem at hand, feasibility, and again, leaning on that engineering judgment, your expertise. And then, of course, as always, we're kind of reflecting on how ethical are the solutions that it's giving us, our use of it, our safety, and just standard compliance with the university or any sort of like review board you might be working with. But this is kind of what I was mentioning earlier, but it really is that trust but verify. So it's not that we're necessarily suspicious of it, but you've got to be aware of the realities of the situation. So it's not to say that a majority of what it's outputting is junk, but as we were kind of playing around with it earlier, you can see it's just a little misalignments. It's doing its best, but it's not a human. So it doesn't have the ability to look at something and go, that looks a little goofy, that doesn't look quite right. So it's our job to kind of hunker down and stick through all of this AI nonsense and lean on that judgment. So when it comes to building up that intuition, I kind of just try to give a few definitions of what those big 5 areas are, and just some general questions you can kind of start asking yourself as you're going through maybe the solve method or just any sort of general play that you might have with the tools that you're using. So when we look at assumption and inputs, it's a lot of asking about yourself. What assumptions did I make when I was framing the problem? Because if you're using like ChatGPT, it will latch on to those assumptions, and it can create like an entire narrative around one subconscious assumption that you made. So it's important to reflect on that and be aware. You're asking yourself, what are the input values, boundary conditions, data sets? Are they realistic? Are they appropriate? And did I clearly specify the constraints and context in my prompt? So we were talking about prompt engineering versus context engineering. That's kind of around that. Then we have accuracy and verification. So asking yourself, how can I independently check this output? So we were talking about mathematical reasoning, your actual manual calculations, possibly even simulating it on some sort of tool where you manually code, or finding some sort of literary reference or textbook reference that can kind of back up the information that I'm finding. Some simple things are the units correct? The magnitudes, the trends physically reasonable? All of these things are kind of taken for granted, I think. You see the numbers and you go, oh, great. And then you don't even notice that it's like a totally wrong magnitude. So these are little things that students often miss out on too. And that's what kind of gets them caught in the act. When we look at applicability to the problem, this is kind of going back to that solve method, but is the output even relevant to what I am prompting it to do? Does the solution actually address the stated goals? Does it acknowledge the constraints I gave it, or does it kind of gloss over things? Something that came up in like a discussion I was having with someone was, I think it was when we were talking actually, the more prompts you give it at once, the more likely it is to gloss over it. So sometimes it's a matter of just going step by step, which again kind of reinforces your knowledge of the topic if you know how to break the problem down and ask that question appropriately. That in itself is building up the intuition. When we look at feasibility and engineering judgment, asking ourselves, would the solution work in the real world under real conditions? A lot of times the outputs are idealized. They're looking at these sort of theoretical fun world versions of life that aren't actually possible. So it's important to see the feasibility of that. And then also looking at our resources, costs, and manufacturing constraints considered. And kind of, again, reflecting on your expertise as my engineering intuition, something that, as a student you've been developing, hopefully over the 4 years you're in your program. Does it kind of align with that? And then when we look at ethical, safety, standard compliance, does it align with my professional standards? Does it align with my university codes? Things like that. So these are, I'm about to go through another series of tables. Again, I hope that these are helpful for you after the fact, because I'm going to go through some different elements of kind of engineering design and look at how generative AI can be used and give an example. So all the examples might not necessarily make sense in your particular context, but just hopefully kind of giving some examples and then emphasizing it as an assistant and not a replacement. So with brainstorming and conceptual design, we have a few here. I think one of the coolest ones is probably generating the alternative concepts. I really do enjoy generative AI for brainstorming. Some of my favorite classes in school were the ones where it was like, oh, I'm learning how to use CAD design, and you just sit with a group of people and they give you some outrageous problem, and the whole point is to come up with a solution no matter what the feasibility matters are or anything like that. It's just, what solution could you possibly think of? And I think ChatGPT and Claude and all these tools are really kind of a fun partner to play around with in that way. So, the emphasis here is that it's offering those diverse directions for design, but it's the student's job to actually filter those, kind of like how you would do in traditional brainstorming, by then you start adding in your constraints of feasibility, like costs, manufacturability, things like that. Code generation and debugging is also a really big area. There's a lot of tools that are literally just for coding. A lot of plugins for things like Python and RStudio and things like that. So these are all just different areas that those tools can be used. I think my personal favorite is just explaining errors. And I think that's probably the most useful to students as well, because even when you prompt these tools to give you code, almost always there's going to be a bug. Sometimes it's just as simple as you're using a newer version of the tool than they gave you the code for. And so it's just one little thing. And when you start kind of trying to reason your way through what's the problem with this code, this to me is kind of where it's able to give you that explanation, but not necessarily solve it for you. Okay. So we have simulation and modeling support. This is one that I don't necessarily have a lot of expertise in, but I have seen some very interesting papers about. I've seen some very interesting, I don't know if anybody likes to go in YouTube rabbit holes where you just kind of start watching videos about things that you have no reason to watch them for. This is kind of my area for that. I love watching the simulations come to life. A lot of times it's like the model setup and assistance is kind of the area that gets people started with it. I know a lot of people who started out in industrial and kind of moved specifically into like manufacturing and mechanical through the use of tools like this that help them with, it's one class they have to take and then all of a sudden it's their passion. So I think things like model setup are great because it's helping you with those templates, but it's your job to refine it and actually get that hands-on experience. And then we finally have our technical writing and documentation. I think this one's kind of the most common and apparent one we're all familiar with, mostly because a lot of these tools are text-based tools. So, things like drafting reports and white papers are kind of obvious, summarizing results. But I think when it comes to like formatting and style guidance, that's something that's interesting to me. We were also kind of talking about when somebody turns something in and it's all bullet points. That's kind of like how it's been created by some sort of generative AI. And so I don't think students really realize that you can interact with it in a way where it can be set up in like a narrative form or a formal report form. And so creating templates that they can input into these AI tools and use to help them kind of generate content that's specific to the courses that they're working in, something that's really cool. So overall, some key takeaways here is, again, that just as everything as it was with the skills, as it was with the way you can interact and solve problems, you're just expanding the possibilities, just like how we're expanding the skill capabilities. Students have to learn those AI literacy skills and those application skills in order to effectively be problem solving. But the weird thing is that it's sort of a symbiotic relationship where they develop those skills by just starting to play with these problem solving tools. So human expertise does remain central. Again, it's that critical thinking, creative thinking. So these engineers have to critique, validate, and ethically apply those AI outputs. And so, ultimately, curriculum should prepare students for that human AI collaboration in engineering practice. So, again, as we were talking about, I think we had a great conversation earlier, but creating assignments in a way, creating classwork in a way that engages them with AI without letting AI kind of overtake the core purpose of that class. But just finding a way to kind of subliminally teach them these skills. It's not like they're taking a whole course on AI literacy. It's more about having them practice with it in a way where the more they get that hands-on experience, the more they kind of identify problems, the more they're building up that intuition that we all need. So, with that being said, this would be part 4 on that module, that document I have in that worksheet, is our last activity for this module, where I kind of want you guys to start kind of building up your own AI intuition. So it's another instance where I give you guys some prompts. You can input, whatever prompts you want, but it kind of takes you through a series of questions that fall under each of those categories of your AI intuition, and just kind of asks you to start reflecting on some of those questions I provided, just to kind of see if you're thinking critically about the responses that are coming out and kind of showing you what it might look like for students. So we have quite a bit of time for that. I think we have, yeah, perfect. We have about 30 minutes for this. So I kind of was hoping we could spend a bit more time on this versus like the solve method. So in groups or individually, please feel free to start playing with that part 4 on the worksheet, and I'm excited to hear how it goes. Okay. a bit more direct. Because that's the hard thing to doing heavy theory, to conceptualize a way to I'm wondering where everybody kind of ended up. I don't know if everybody was able to get through it all, if they got kind of caught up with certain steps. Is anybody able to finish the whole thing? Nobody. Okay, that's fine. That's a good thing. You mentioned something great when you came up when we were talking a little bit, and talking about kind of seeing things from the student's perspective. And I think that's something I want to emphasize, especially with some of the activities in this module, is that, obviously it's important for you all to have your engineering intuition and to, learn how to solve these problems using AI. But I'm sure, most of you are familiar or have a lot of make sense, in your interactions with AI. So I hope what kind of came out of these activities is how students might be encouraged to think about them and kind of have a systematic way to process information that's coming back to them using AI. So I don't know if anybody kind of had any sort of realizations or questions or anything they wanted to bring up from this last activity where we're kind of talking about building intuition. If you didn't get through the whole thing, I won't be surprised if there's nobody has anything to say, but I was just curious, especially because I know it was kind of this small prompts for big questions, So I encourage you guys to keep playing with these questions for prompts that are more relative to like the work that you will do when you want to implement in your class, because again, it really is just a sort of a framework to help students start volleying back and forth with AI, and encouraging that instead of just taking it and applying the information as if it's 100% true no matter what. So we have a few minutes left in this module. I can give you more time to work on that if that's what you want, or you can keep playing with the modules and the Gen AIs and kind of see what's happening. I have other tools that I can show if that's kind of what you prefer. Okay, looks like that's it. Okay. So there's one in particular I think I mentioned earlier. I was really interested in kind of literature reviews and things like that. And one of the tools, oh yeah, I don't know if everybody saw this when they came back in. This was one of the design results from that prompt we inputted into ChatGPT. So we ended up putting it in ChatGPT. It gave us kind of like a gave us that. Then somebody recommended we put it into Sora with ChatGPT, and it gave us this. We were trying to discern how good that was. Visually, obviously, it's pretty appealing, but as how accurate is that information? How relative is it to the actual assignment? That's still to be determined. But this is another instance where you can practice that intuition. Obviously, you have like the literal technical information that's being output, so you can exercise like, is this correct as far as I know? Comparing it to literature that you might be utilizing in class, or just any sort of peer responses that you can interact with other experts. But on top of that, obviously you have the actual deliverables like beyond the images. How do they align? Is it making any assumptions that I didn't prompt it to make? Are those assumptions correct? Are they kind of notifying me of something that I didn't think about beforehand? Or is it making incorrect assumptions that I really need to kind of take care of now so it doesn't keep building on those incorrect kind of ideas? So that's kind of an interesting one. But yeah, so I mentioned before that I like literature reviews. I like, it's a big part of my life right now as a student, but this tool that I've kind of found recently called Elicit is really fascinating. Sometimes I'll just put in like a term, not even like a question, and I'll just kind of see what it generates. So let's see. I think I had, oh, here they are, yeah. But, oh yeah, go ahead. Elicit, ELICIT. So yeah, I mentioned before that I used to do physics. So I was thinking about quantum fluctuations the other day. So I literally just wanted to see what people were saying about quantum fluctuations. And it basically wrote me an entire paper about just defining what quantum fluctuations are. And it also gives me an enormous table of sources, some pretty relevant, some pretty recent, other ones pretty foundational. Gives me study focus, methodology type, scale of investigation, key contributions, and full text retrieved. When it says no, my understanding at this point for full text retrieved is that it's behind some sort of paywall. So, sometimes my university has access to it if I can find it. Other times it's kind of like obsolete. But this has been pretty interesting for me so far. It also gives other details like it'll kind of aggregate information about them. So for methodology type, 8 studies use theoretical analysis, 1 study used experimental investigation, 1 study used theoretical review. Gives scale investigation, key contributions, so like the main scientific themes. And then it performs thematic analysis on all these papers and pulls out sort of key terms that they're using to describe quantum fluctuations. And I mean, it was kind of fascinating because, again, I literally just typed in quantum fluctuations. I had 0 questions for it. I was just kind of curious what would happen. So yeah, it's kind of like I would consider it like a report of some sort, not necessarily a paper, but I do believe that tools like this can write papers. And so that's a very particular outcome that I think the sort of generative AI intuition and engineering judgment is really necessary for, because it's like bulk content rather than these sort of bullet points that people can kind of quickly peruse. So I don't know how relevant paper writing is to engineering courses at this point. Maybe it's a bit more relevant the higher up you get, when you have to do like independent research and maybe some sort of final exam or senior design project. But tools like this are interesting, and I think it's one of the most difficult ones to practice that intuition on because it's not often required. Versus something like a homework assignment or a quiz, which is like every week, every 2 weeks, whatever. And the content of it isn't so dense. So this is just something I thought I'd kind of show because it's very different from some of the other tools I think that people have seen. With things like ChatGPT and Claude, it's again very text-based, image-based, but it's formatted in a very distinct way that is kind of common across all of the tools. And then you have things that generate code, which code in itself is pretty standard. Obviously the syntax would be different from whatever language, but kind of is formatted in a similar way. So this was just something I thought was very interesting, and I think it's a positive because it gives you tables like this and it gives you accurate references that you can double check. So this would be an interesting tool, I think, to build that intuition around sort of narrative type writing, report writing, just because it seems to give some of the bulk things that you need. Going back to things like ChatGPT, though, I mean, this was one. I think this was a pretty good example that we put in with the bicycle design because, I think that having that multimodal aspect of it with the images obviously kind of brought it home how when it takes the information it's giving you and uses that to visualize, you can literally see how there's missing components from the information because it's like a physical representation of something that they gave you. So it's kind of clear there, but this is another tool that I hope that you guys can take some of the other examples that I have in that Module 5 document and kind of pair them with the activities from this Module 6 and kind of keep playing around with it, keep trying to see it from student point of view, and kind of apply that knowledge to the assessments that you're currently using, maybe finding ways to adapt it, so that it kind of builds in subliminally practicing that generative AI intuition and building those literacy skills. So I think we're kind of at the end of this module. I, of course, can continue putting in prompts if that's what you want. We only have about 4 minutes before it's time for lunch. But I hope this was helpful for you. I know it was a lot of like independent group work today. But I hope it was kind of what you came looking for, and I hope it was an opportunity to have some hands-on practice with some of the information we've been sharing so far. So thank you. I appreciate everyone's attention. It's lunchtime. Okay.